In this video, we're going to talk about combining intervals, which means stacking them on top of each other. We talk about intervals either as frequency ratios or as a number of cents. So when we combine our intervals, we can work in both ways. Now, in terms of frequency ratios, the size of the combined interval is found by multiplying the constituent frequency ratios. For example, if we had a perfect fourth and a perfect fifth, we know that a perfect fourth and a perfect fifth will add up to an octave, like C to F, F to C would be an octave. We also know that a perfect fourth is an interval ratio of 4 to 3, and a perfect fifth is 3 to 2. So we can work out that an octave is a combination of the 4 to 3 and the 3 to 2. So 4 over 3 times 3 over 2, which is equal to 4 over 2, gives us a ratio of 2 to 1, which is an octave. Let's have another example. Some common intervals are a major third, 5 over 4, a minor third, 6 over 5, a perfect fifth, 3 over 2. We could use this information to work out what the notes were in an A major triad, given that the root would be 220 Hertz. 220 times 1 is 220 Hertz, so that's the unison. C sharp would be 220 times 5 over 4, and E4 would be 220 times 3 over 2. Another way we could find the E is to just combine the major and the minor thirds, because perfect fifth is a major and a minor third added together. But because they're frequency ratios, we have to multiply them. So the answer would be E4's frequency is 220 times 5 over 4 times 6 over 5, which is the same as 220 over 6 over 4, which is the same as 220 over 3 over 2, which will give us 330 Hertz, but we know 3 over 2 is the interval of a perfect fifth. Now, when we're dealing with cents, it's different. Cents are already a logarithmic scale, so that means when we want to add the intervals, we can just add them together. They will automatically be doing the ratio multiply. So, to build our A major triad, we would have our base frequency of 220 for the A. C sharp 4 would be the interval 386 cents above 220 Hertz, and E4 would be that interval with a minor third on top of it, which is 316 cents. So we would get the right notes, but if we wanted to, we could get the interval A to E by just adding 386 plus 316 cents, which would give us 702 cents. So we would work out the interval, which is 702 cents above 220 Hertz. To summarize this, when we're working with frequency ratios, we need to multiply the intervals together. But when we're working with cents, we can just add them together. Here are some questions for you to answer. This is regarding frequency ratios. You can pause the video and work on that. And when you're finished, the next one will be in cents. Here are some questions combining intervals working in cents.